The objective of this video is to introduce geometric sequences and to find the sequence from the formulas and to find the formulas from the sequence. Now you may recall we did arithmetic sequences before. Arithmetic sequences where you would list a sequence of numbers, just a list of numbers, where every number you just added the same thing to get to the next one. Well, in a geometric sequence, like this example 1 down here, notice that 26 times 2 gives you 52. 52 times 2 gives you 104. 104 times 2 is 208. So you're always multiplying by 2 to get to the next term. So a geometric sequence is when you multiply by the same term, same ratio to get to the next term. Now, on this, the recursive formula, if you recall from when we did this, recursive means that you list the first term and how you get to the next term. So what are you multiplying by to get to the next term is what you define. So down here, notice that we define it as 26 is our first term, and then we multiply by 2 to get to the next term. Now, explicit formula, you want to be able to say, instead of just always going a full list to get to the next term, how do you jump to a term? So this allows you to use a formula to jump to a term. Like to the 100th term or to the 1000th term. Now, we list sequences. Usually we go a sub 1, and then next one would be a sub 2, and then a sub 3. So we use subscripts to list them. When we do a recursive formula, we define it by saying a sub n, whatever n would be, like we had n equal to 1, 2, and 3 that I just listed. That would be equal to listing the first term for n equal to 1, and then to get to the next term, you would take the previous term and multiply by r, which is a common ratio for n greater than 1. So r equals the common ratio and you calculate r by taking any term and dividing by the previous term. So any two terms in the sequence, the second one over the first one will give it to you. So for instance, on my listing down here, if I took 208 divided by 104, that would give me 2. That would be my common ratio. Now, explicit formula is a formula that you can just jump to. So you say, we're going to say a sub n equals, and you got to tell us what the first term is, a, and then multiply it by that common ratio to an n minus 1 exponent. Now notice that this is an exponential formula. So that's why this is in this topic, is that the geometric sequences is a form of exponential formulas. So let's go down to our example here, and let's go ahead and talk about, and this a, just so you know, the a is the initial amount or a sub 1. It's your first term. All right, so let's go ahead and do this with this example. Let's list the formulas from it. So recursive, we're going to list a sub n is equal to the first term. First term is 26. So we just list that for n equal to 1. And then we outline that we're going to do a sub n minus 1, and we're going to multiply by a number to get to the next term. Well, the number you always multiply by is 2. That's that common ratio for n greater than 1. So notice that we get that because you can get r by taking any two numbers in the sequence and take the second one over the first, and you get that common r ratio that is you're multiplying by each time. All right, now what if we had, let's do the explicit formula for this one. Using our format for the explicit formula, we're going to take and make a sub n equal to the first term, which is 26, times the common ratio, which is 2, to the n minus 1 power. So if we wanted to find the 10th term, you do a sub 10 is equal to 26 times 2 to the 9th power, 1 less than the 10. Because the first term we don't multiply by the 2 to get to the first term, so it's always 1 less than it. All right, let's look at our second example here. We're given the recursive formula. We want to find the 13th term. To do that, let's just take a look at what this formula would be, this sequence would be. So we start with 11, and then it says to multiply by 4 each time, so we'd have 44 for the next term. And then we'd have multiply that by 4 and you get 176. So this would be a sub 1, a sub 2, a sub 3, and you could keep going. You could go all the way out to a sub 13, but let's list the explicit formula instead because that will allow us to just jump straight out to it. So explicit formula would be a sub n equals, and we list the first term, 11, times the common ratio, which is 4, we're multiplying by 4 each time, to the n minus 1 power. So if we want to find a sub 13, that's going to be equal to 11 times 4 to the 13 minus 1 power, which is 11 times 4 to the 12th power, which if we multiply that out, we'll get 184,549 and 184,549,376. Very large number because these go up so fast because they're exponential. All right, so in review, what we're doing here is we're talking about geometric sequences where you start with a certain number and then you multiply by the same number to get to the next one. We've got our formulas for finding those. We've got our recursive formula, we've got our explicit formula, and both of those have their own purposes. The recursive tells us how to get to the next term, tells us what we multiply by each time. The explicit formula allows us to jump to a term somewhere in the sequence. Like this last one, we jumped to the 13th term by putting in the first term, 11, times the common ratio 4 to the 13 minus 1 power, and got our final answer. So our objective was to find the sequences from the formulas and also use the formulas to come up with the sequences. So we're using that to find information about geometric sequences.